Have you ever wondered what's in your water? According to dilute water filters, on average, 250 million people each year die because of contaminated water. There are many things in the environment that have the potential to harm you that are in contaminated water. This is why this experiment is so beneficial. My name is Maggie Dominic, and the purpose of this experiment is to identify unknown compounds found in drinking water samples supplied by contaminated water. Determining the unknown compounds can be achieved by using infrared and nuclear magnetic resonance spectroscopy. Using the equipment given in the lab, the IR and NMR spectra could be obtained. For IR, an IR spectrophotometer was used by placing a small drop of the water sample onto two salt plates and inserting it into the machine. The IR spectra was then printed out visually. The IR spectra was used to determine the functional groups that correlated with what range of absorbance. Each functional group has its own range. According to Master Organic Chemistry, a functional group is a specific grouping of atoms with molecules that have their own characteristic properties. For NMR, an NMR spectrophotometer was used to determine the spectra of the unknown sample number 34. A small amount was placed into a tube and then placed into the NMR reading machine. This machine then detected the number of peaks and the ratio of areas contained in the sample. NMR spectra gives two pieces of info: how many hydrogen atoms that are present and the relative numbers of each type of hydrogen atoms. This info was used to match the number of peaks and the ratio of areas to the functional groups found in the IR. Using both IR and NMR, the unknown compound can easily be determined. Table 1 shows the functional groups that are present in each compound. By analyzing the functional groups found in each IR spectrum, the compounds can be determined for the solutions. Table 2 shows the number of peaks and the ratio of areas present for the compounds. By analyzing the number of peaks and the ratios present, the NMR spectrum can be determined. These two images explain the functional groups that were found in the IR spectra of the unknown compounds and the number of peaks and the ratio of areas for each NMR spectra. For the unknown compound 34, the first step taken was to look at the IR spectrum and determine which functional groups were present. It was found that CH benzene ring and CH singly bonded carbon were found in the sample. Looking at table 1, two molecules had both of these functional groups present. The NMR of unknown 34 showed that there were 2 peaks in a 3:2 ratio. Looking at table 2, it showed that para-xylene had 4 peaks reduced to 2 and a matching ratio of 3:2. According to the Agency of Toxic Substances and Disease Registry, it states that this molecule can leak into soil and ground or surface water, which can be harmful if the molecule doesn't have time to break down or evaporate into smaller organisms. If it is left at high exposure, it could lead to death in animals that ingest or inhale it, but other parts of the environment may not be affected. The effects found in humans, according to xylene, an overview of its health hazards and preventative measures, states that if this compound is inhaled, it can range from acute to chronic effects. The main effects that it suppresses the nervous system, which can cause symptoms of headaches, dizziness, sleepiness, and loss of consciousness. It can also damage the liver and kidney, but won't go unnoticed because of the previous damage. 34.1 sample contained an NMR of 1 peak in a ratio of 1. In table 2 matches up with acetone, 1,2-dichloroethane, and benzene. You have to look at the IR to limit it down to 1 molecule. The IR spectra for 34.1 in table 3 shows that this sample contains CH singly bonded and C double bonded O, which matches up with acetone and other molecules such as ethyl formate, acetate, and methyl acetate. By using this information from NMR, it can be determined that sample 34.1 contains only acetone. According to the National Pollutant Inventory, acetone is not very harmful. It occurs naturally in the environment, and if it is in liquid form and escapes a container, it is easily and quickly changed into gas and can evaporate. If it is in soil or water, it can break down easily and not cause harm. According to the CDC, acetone is not harmful to people, but it depends on the amount of the chemical that people are exposed to. The most harm it can cause is headaches, dizziness, and nasal and throat irritation to those exposed to large amounts for a prolonged time. Sample 34.2 had an NMR spectra that contained 3 peaks in a ratio of 3:2:1. Using table 2, it can be seen that ethanol and ethyl formate both contain these NMR spectrums. This sample also contained an iron spectrum that had OH bond and a CH singly bonded. Functional groups, these two functional groups were also found in methanol, ethanol, 2-butanol, and 2-propanol. But using the NMR information as well, it was determined that the molecule contained the same ion NMR as ethanol. According to the U.S. Energy Information Administration, pure ethanol is non-toxic and biodegradable. If a spill occurs, it is able to break down into smaller substances. It can become more dangerous, though, when other chemicals are added to it to make gasoline or fuel ethanol. This is when it has to be treated more carefully during transport and use. This type is highly flammable and can be harmful on ground-level ozone, causing smog and pollution. For humans, ethanol is not dangerous as it is in the environment. According to toxicological effects of ethanol on human health, if it is consumed in forms such as alcohol, it can reduce stress and promote feelings of happiness. But overconsumption of ethanol can lead to addiction, which can further damage internal organs. Looking back on the information, the unknown sample 34 was found to be para-xylene. Unknown 34.1 was acetone. Unknown 34.2 was ethanol. These were all found by using IR and NMR spectroscopy. Thank you for listening to my presentation.